Now we want to look at recurring decimal. What's recurring decimal? Recurring decimal. This is a decimal fraction in which the same figure or group of figures is repeated forever, that is till infinity. Recurring decimal, don't forget, this is another expression of rational number. Said rational number can be expressed as terminating or recurring decimal. And recurring decimal is a decimal fraction in which the same figure, that is one figure or group of figures, is repeated forever. Now look at an example. Let's take an example. For example, we have 3.9999. Now this 9 is repeated. The same figure 9 is repeated again and again and again. It's repeated forever. So we can describe this. 3.999 is also described as 3.9. When we write 3.9, we mean that 9, the figure 9, recurs indefinitely and the decimal does not terminate. Other examples, we may have 0.27, which is equal to 0.272727272727. That is, the 27 repeats itself indefinitely. It doesn't have end. It repeats itself forever. So we can just pick the group of figures that repeat itself, which is 0.27. So instead of writing 0.2727272727, which is indefinitely, we can just pick 27. That means this 0.27 recurs, the 27 after the decimal point recurs indefinitely. You may have a 0.207, which is 0.207, 207, 207, 207, 207, and so on. You can see. So we can describe this as 0.207 and we can describe this as 0.27. So now let's take examples, proper examples. So I believe you understand recurring decimal, decimal fraction in which the same figure, just like this, 999, repeats itself forever. It doesn't have an end. It doesn't terminate like that terminating a decimal or group of figures. This is an example of group of figures. 27 repeats itself. 207 repeats itself. It's an example of group of figures, and this one is just a figure, the 9 repeating itself. So this is 0.27 is describing this. When you dial the digits on your calculator and you have results like this in recurring decimal, then you just need to pick the figure or the group of figures that repeat itself, so which is just 27 after the decimal fraction. And for this, that repeats itself, we just have 0.207. Okay, so let's take example. We say express as a recurring decimal. Now number one, we have 1 divided by 3. Now 1 divided by 3, uh 1 divided by 3, you have 0.33333333, and this 3 repeats itself. This one is just a figure, the same figure repeating itself, so we can just say this is 0.3. Okay, since it repeats itself, just say 0.3. Another example, example 2, we have 1 over, let's say we have 2 over 3. Now 2 divided by 3, that is 0.6666666, and this 6 repeats itself, so we just say 0.6. The 6 repeats itself. Only when you want to approximate, you can just say 0.7 as your final answer. If there is need for you to approximate, you just say 0.7. But in the recurring decimal, the number that recurs is 6, so we can just say 0.6. Okay, just say 0.6. 2 divided by 3 gives 0.66666, so we just pick 0.6. How about we have 1 over 99, we have 0.010101, and so on. So we can just say 0.01. That means 01. This group of figures repeat itself. You can see 01, 01, 01. Definitely you still have 01, 01, 01. Definitely you still have 01, 01, 01. So instead of repeating it, just say 0.01. How about we have a larger denominator? We have 0.001, 001, 001, and so on. So now our answer will be what? 0.001, because 001 repeats itself. This group of figures repeats itself, so we can just say 0.001. Example 5, we have minus 5 over 11, and this gives us minus 0.45454545, repeating itself. So what do we do? Our final answer will be minus 0.45, since this group of number repeats itself. Another example of recurring decimal, we have number 6. We have 65 over 7, and this gives 9.285174285714.